Sip on mezcal, I like tequila, damn this shit tasty. Yeah, you know I made about $1 million off a pink beanie. I feel like my life is a movie, damn this too easy. Can't catch me, I'm jumping the borders, hit the embassy.
Hey bro, what's up?
Yeah, hi.
So today we have an interesting guest. Yeah, bro, how old are you?
22.
He's 22 years old. He's 2 years younger than me. And he's running a non-profitable organization which promotes space education among schools.
Yeah.
And also he owns a SpaceSkool. Is it SpaceSkool?
Yeah, it is.
It also teaches people on how to get, how to get a good career in space.
Yeah,
in
kind
general,
of.
Right? Okay. So I'm going to ask you this question, bro. This is like, it's been on my mind for so long. Does that intelligent life exist outside the solar system?
Yeah, I wish I can go for a trip throughout the solar system. Maybe I'll know. Yeah, it's a quite interesting question, but and it's quite difficult to answer. It depends on what perspective.
Do you really think like we're so alone in this space?
Hopefully there are some alien life or extraterrestrial life out there. Like as Carl Sagan said once, universe is a pretty big space. If it is just us, it's quite awful.
Yeah, we are so fucking alone in this planet. if there is no life, but I do think there is life. What do you say? Like, you don't believe that aliens exist?
I wish they exist, but
they're not as smart as us, so they could.
Yeah, when we are talking about extraterrestrial life, like as we see in science fiction or cartoons, they don't need not to be have it 4 eyes, 4 legs or something like that. It can be some microbial life also.
Yeah, that's what I was thinking as well. It doesn't need to have like 2 big eyes and just triangular face.
Yeah.
And then they all for some reason just go and attack US for no reason. And India, France, they doesn't exist for these aliens.
Yeah.
And US is the only country all these aliens want to attack, and some guy with 2 guns saves the planet.
Yeah, maybe in science fiction, like the aliens need not to be having 4 hands with 4 guns to shoot against.
So there is a possibility, right? I'm talking about, maybe I'm talking shit, but I think they exist. Like the universe is expanding, right?
Yeah.
At a really faster rate, or no?
Yeah,
why does it expand? Like, can we answer that?
Yeah. So for the first question you have asked, is it expanding very fast? My answer will be like, yeah, it is expanding really, really fast, more than the speed of light, which is nearly 3 lakh kilometers per second.
Okay, so there is something which is faster than the speed of light?
We can say that it's expansion.
Okay.
Yeah. So as theory saying that there is nothing can go more than speed of light, because light is photons, right? Light travels like photons. Like photons doesn't have mass. Okay, so it can go with the speed of light, which is nearly 3 lakhs kilometers per second. Okay, so yeah, if we want to achieve speed of light, even a small object or whatever the space,
even this small tissue can't achieve the speed of light because it has its mass.
Yeah, it has a mass. Like when it is traveling near the speed of light, it gets infinite mass. Okay, so to move that object, which is going in the infinite mass, it requires infinite energy, right? So how much energy is required if you want to throw that tissue paper in the light of speed? So you have to calculate with equal to mc square formula.
Okay, so I need to have infinite amount of energy in order for it to travel at
because it is going at a 3 lakhs kilometer per second, right? So it requires it gains a lot of mass. Okay, when there is a lot of mass, you definitely require a lot of energy, right? To get that energy, it is quite impossible.
Okay, so theoretically speaking, is it impossible for us to achieve the speed of light?
Until we get enough energy,
Okay, so we need to have this kind of infinite amount of energy in order for us to achieve the speed of light.
Yeah. So the weight of this coffee cup is different when it is in the state of rest. Okay, the mass of this cup will not change until we didn't move it. Okay, so when we are just moving it to another place, like while it is in the motion, okay, so the mass will be different.
Okay.
Yeah, because it is going with some different speed.
Mm-hmm. So if I want to travel at the speed of light,
Okay.
I need to have no mass, or I need to have infinite amount of energy.
It's not just enough.
Okay.
It's not just enough, but it's also a requirement.
A possibility. Like,
Yeah.
do you think it's possible for us to time travel with the speed of light?
Okay, so there is different kind of answer for this, like based on what perspective that you're talking.
Okay.
So if you want to time travel, like if you want to get into future, it is possible. Like if you ask me how, so for example, if you're going on a spaceship, like on a rocket, okay, with some speed of light or near to the speed of light, okay, so if you just go, like if you go around the solar system, like if you just go for a trip around the solar system, if you come back here, it will be like if you travel for a near the light speed in space, and if you come back to Earth, okay, so all your friends will die.
Okay,
because,
why? I don't want my friends to die.
Because when you are traveling in space with high speed, okay.
Okay.
So
a year to me is like the 100 years for these people.
like it depends on
The speed.
It depends on the speed.
Okay.
Okay.
So that what happened in the movie Interstellar.
Kind of.
Okay. So based on what you said before, the faster you move, the slower the time goes for you.
Exactly. This happens because the clarification was given by theory of relativity, which gave by Einstein. Okay. So there is a concept called time dilation.
Okay.
So
this is what I am interested about.
the time will go slowly when it is having higher gravitation, like higher mass. Okay. So this gravity works, we know, like Newton said something, right? And the Einstein come up with this theory of relativity, which changed the whole understanding of physics and the gravity. Like what Einstein is saying, that the space is a kind of fabric. Okay.
Yeah.
So there is a fourth dimension called time, what Einstein said. Okay. So they have, there is a concept called space-time. Okay.
Yes.
Okay. So this gravity works based on this thing. Okay. This fabric of space. Okay. So let us imagine, like everybody gives this same example even you go to YouTube.
Yes.
Okay. Yeah. When it's just like a fabric, if you put some heavier object, it will create a bend in the space.
Yeah.
Right. So this is why if you throw some balls around it, it will orbit through the bend. Okay. So this is how gravity works. There is, the sun is very mass. Like it is having greater mass. Okay. So that is why planets around the sun are revolving around it. And even the Earth is also having some mass, right? So this is why moon is also orbiting around the Earth, because it also creates some curvature in the fabric of space.
Okay.
Okay.
And how does time relate to that?
Okay, so how time relates to that, there is a called time dilation. Okay, so as you are on the Earth, there is some gravitation. Because of that, time goes little slower for you.
Yeah.
Okay, and if you ask me that question, whether the time changes or not in space or something like that, there will be difference, but based on what situation that we are talking.
Okay, so if an object is at rest, it will perceive time differently than the object when it's in motion.
We can't say an object. Maybe we can say an object like a like
like
what
a
that
person.
object defines. Like we have to define what's that object.
Okay, so if I'm here on Earth,
Okay.
and my friend goes to Mars,
Okay.
is it true that like he can't age that much as I do? Like, I mean, a little bit of change is there.
Yeah, but you have to, you have to tell the proper situation. Okay. So if you're traveling in space.
No. I'm asking, like, is it true that?
Yeah, it is.
Why does these astronauts age differently than we do?
Okay, so if you have a friend astronaut, who is in space, so if he is traveling in the International Space Station, if he is traveling in the International Space Station, which goes 28,000 kilometers per hour, so the age will be, the astronaut in the International Space Station will be younger than you. So if he is not in the International Space Station, if he is, orbiting the Earth with less velocity, let us imagine with less velocity, like you just, the astronaut is just floating in space, so he will age older. Okay, if he is traveling in the International Space Station with higher velocity, he will be younger. If he's just
because
floating
he's traveling
in space,
faster than the rest of us.
So in time dilation, there are two concepts. Okay, so which depends on one is relative to gravity. Okay, so gravitational time dilation, and there is based on velocity. Okay, so when he's just floating in the space, he's not moving with higher velocity. He's just moving in space, just like floating. Okay, so the gravitational time dilation will be greater than that velocity time dilation. Okay, so the gravity is higher than the velocity there. Okay, so that is why the magnitude of gravitation is higher for us. Okay, so that is why we is lesser younger than the astronaut who is just floating with lesser velocity in space.
Okay.
If he is traveling in 28,000 km per hour in International Space Station, or if he is going with more speed or near to that, okay, if he is going in higher velocity, he or she, okay, so then they are just younger than us, because the velocity time dilation will be higher. It affects more than the gravitation.
Okay, gotcha. So, okay, imagine I have a friend who is in the International Space Station. I have this doubt for a really long time.
Okay.
What kind of food they eat?
Okay, so I'll not tell you that they have to take a pill like when we listen, right?
Okay, is that not true?
No. Like when we think that like astronauts are going to space, they just take a pill, like there is a kind of myth. It is not true. They can eat burger, they can eat pizzas.
They can?
Yeah.
Oh.
Yeah. They can eat what they want, but not everything that they want, but yeah, they can choose what kind of food menu they want to eat.
Okay, so if they're eating whatever they want, they can use salt and pepper and everything.
Yeah, they can use salt and pepper, but in a liquid format.
How?
Yeah. Yeah, for example, if you have something, okay, you want to, if you want to use some salt or pepper on that, okay, if you just do that, it's just small particles, right? There is microgravity. Okay, everything just floats away. Due to microgravity, if you just throw that sprinkle that salt or pepper on that,
it'll just float.
It just float. It can go to the eye, get into the eyes, nose, into the astronaut.
And there might be a possibility that it can also damage some parts of the
whatever the spacecraft that they are into. So they use in that liquid format. Okay, so what they have to do is that if they are using some kind of food, they'll just pour it the liquid and they'll do that. So the chances are very less, right? Even it just floats, it floats like a bubble.
Okay.
They can just handle it properly.
So there are like different domains in space. You have a lot of people working behind the scenes, to make the spacecraft.
Yeah.
And to make food and get the machines running. You have to have like all kinds of people in there to, like set it up, set the whole thing up. So if I want to become an astronaut,
okay,
what kind of degrees do I need to do? Or if I want to work in space industry, what should I do?
Whatever you do, like whatever you want to do, you can do to be a space scientist. Okay, so you don't have to study aeronautical engineering. You don't have to study aerospace engineering to be an astronaut or to be a space scientist. Okay. You study medicine, you can be an astronaut, you can be a space scientist.
I can be an astronaut if I study medicine?
Yeah, of course. Okay, for example, like you are going to space. Okay, let us imagine like we are not in 2020. Okay. So let us imagine we are in 2050. A lot of astronauts, a lot of people who goes to space travel, like just for a tour, like 3 days or 5 day trip.
Thanks to Elon Musk.
Yeah, thanks to Elon Musk. Okay, so if you're going like that, okay, so you require a lot of people, right? Like it's not just aerospace engineer is enough. Like when you're traveling in space, you need a lot of things, right? Whenever you see or whenever you watch some photo or video in YouTube about the space travel or the astronauts who are in International Space Station for some meets or something, you see they'll have all side computers. Like you can see wherever you see there will be filled with computers. Okay, so if you're an aerospace engineer, do you think an aerospace engineer can handle computer science better than a computer science engineer?
No.
Okay, so we require computer science engineer, right? So you can be a space scientist, you can be a computer science engineer, like you can be a doctor, but you can work for medicine. Okay, so like when we go to space, maybe our human body might change, the metabolism of human body might change, right? So somebody needs to study that. Okay, if something happens to you, right, you can't deal with it as you're dealing with on Earth. The things which are in space are different than where we are here. So we need people to study that. We need people to research that. Okay, so who will do research on medicine, like aerospace engineer? I don't think an aerospace engineer can do best research on medicine or human body in space. So we do require medicine. Like when we are talking about space travel, or when we are talking about traveling to Mars, okay, so it is not just enough if we have a capable rocket or capable spacecraft which can launch us to Mars. Okay, so we need food, right? So that we can live. Okay, so we have a very good rocket, we have a very good spacecraft which can take us to the solar system.
How long is it going to take for us to reach
Mars? So it
Mars?
depends on...
Based on like present scenario.
Yeah, it depends on at what time you're launching. Okay, it depends on...
Okay, so for the orbital thing?
Yeah, okay. So we launch a spacecraft or whatever it is, a satellite or whatever it is, okay, based on when it is near to us, then we launch those things.
Yeah.
Okay, so because if like if we are in this side, if the Mars is on another side, it takes very long and it is not cost effective also. It costs billions of dollars, right? Every kilometer is very expensive. So
we need to take time.
We need to do that. Like most people think that when we are launching some satellites or some rockets, okay, so they do launch in odd timings, 3 o'clock in the morning and 12 o'clock in the midnight. We might wonder why they want to launch it in the midnight or in the odd times. Why can't they launch it at 10 o'clock? We can go have breakfast and simply go and we can come back for lunch. But it depends on like
the distance.
Yeah, it completely depends on orbital dynamics. Okay. So you have a rocket which is capable of going in this specific kilometers per hour with it takes based on that satellite. It goes with a different speed. And if you want to launch a weather satellite, okay, it needs to be put in a different orbit, in different altitude, in a different inclination. If you're using defense, it requires in different altitude, right? So it based on that.
I've also heard that we also use the orbital velocity to make things travel faster, like efficiently.
Kind of,
like using that force of our orbital velocity.
No, when you are doing space travel, okay, so you require a lot of speed, okay, so to go beyond the Earth's gravity, right? So Earth's gravity is something. If you want to go beyond Earth's gravity, you need to go with a certain speed so that you can break the barriers of gravitation.
Yeah, okay.
Okay, so for example, if you throw a ball, okay, it will come down because of the gravity.
Yeah.
If you want to throw this ball to space, okay, if you want to hit this International Space Station with this ball, okay, if you ask me, is it possible? It depends. Okay, at what speed, at what energy that you are throwing this ball. Okay. So if you can break the barrier of the gravitational pull of the Earth, you can do that, right? When when you are throwing a ball, it will come down. Whatever you're doing, whatever you are throwing up, it will come down because of the gravity. Why this rocket will not fall down when it is going to a certain height? Why it is not falling down? There is gravity, right?
Yeah.
Wherever we launch a rocket, there is also gravity. Why it is not falling down? Because we are launching the rocket at a certain speed. Okay, it is breaking the barrier of that gravitation. Like it is going with that speed. Okay, so when it is when you want to send some rocket or some spacecraft or some satellite or some whatever it is, if you want to go beyond the Earth's orbit, you need certain speed to go beyond that. Okay, so you can't, you'll not easily attain that speed that instantly. Okay. What they do is that they launch the rocket. Okay, so it will go in that inclination mode, like it will go orbit around the Earth for few times. Okay, so it gets accelerated faster and faster and faster.
And then
it will be getting enough speed, okay, to break the barrier and go beyond. So we talk about we talk about rockets are going with higher speed, right? So International Space Station is just 400 kilometers above Earth. Okay, so it used to take a lot of hours to go. We are going in 6 hours. Okay, so these days when you have to travel 400 kilometers, like these bullet trains are just taking you in just less than hours, right?
Yeah.
Okay, so even flights, if you have to travel from Hyderabad to here, which is like
600 kilometers,
something, okay, you can just travel in an hour, just flight. If you're going on rocket, it's just 400 kilometers above you. Why you can't just go it in an hour? Why it is taking 6 hours? Because it won't happen like that. Okay, so you launch from here. Okay, this rocket will not go like that. Okay, it orbits the Earth again and again and again. Okay, so it needs to be in perfect inclination. Okay, so that is.
Does it move away from Earth as it rotates?
No, it's not like that. It happens like that. It won't orbit like this. Okay, it won't orbit like that with the same distance. If you want to go beyond Earth's orbit, okay, what you have to do is that you just go orbit like this, and the next thing you will go. You thrust up for even more distance, and you do that. You come here and you do give more boost.
Yeah.
It will go like that, and you go in that.
Yeah, that's what I was saying. So we are using our own gravitational pull in order to get that.
Yeah, we call it as with different names. Okay, this is what. Okay, you have to do that so that it will do that. But for International Space Station, it is not like that. It's just 400 kilometers above Earth.
It just rotates in the same orbit.
Yeah. It maintains to be around 400 kilometers above the Earth's surface. Technically.
But this thing also saves the amount of fuel or whatever we use, right? Using the gravitation to do the whole thing for us?
Not completely. There are few missions which goes to moon or something like that. We use different techniques, and scientists do experiments with a lot of things. If they don't do experiments, then we don't call them scientists. And we don't call them researchers. All their work is to do research and conduct experiments.
Yeah, right? And they also have to do research in a lot of things, right? Like what happens to this particular thing at this temperature.
Yeah.
And at this time. I've even heard that when these people went to moon, we're talking about moon, right?
Yeah.
Do you really think that moon landing was faked?
I don't think so.
I've seen a lot of people, man. My friends just come up to me and say, "Yo, bro, you're so much into space. Do you think the moon landing was real? It's fake, man." They just mock me.
If I
explain them everything, and they still say the same thing by watching a bunch of YouTube videos and shit. They still say the moon landing was faked.
If I say it's faked, from tomorrow I'll not be into this business.
Yeah, I don't get the obsession with all these conspiracy theories.
Yeah.
So, is it true that when Neil Armstrong and the other person went to the moon,
okay,
when they came back to Earth, they made them stay for 14 days or 1 month in quarantine?
Yeah.
Just to see that they didn't bring any kind of infection or something. So we need to have all these kind of people to do all this research, right?
Yeah,
so,
of course you need it.
So just as much as you require rocket science, you also need all these other fields like medicine and I don't know, maybe something to do with herbs and shit, so people can grow plants.
Yeah, of course, it's the booming, right? It's now, this is the topic that is booming these days. Mm-hmm. Okay, so astronauts, scientists are doing experiments on this. They are already planting some kind of crops. They are doing this kind of research in International Space Station. Okay. Why they go to International Space Station? Definitely not to see how Earth looks from space, right?
Yeah, not to take some selfies.
Yeah, not to take some selfies. If it is, even though if we want to see how Earth looks like, we just send 1 or 2 astronauts and that's the end of the story. We don't have to travel all the way. They need not to stay 6 months there and new astronaut will go and come. We don't have to spend a lot of these things. They don't go to space just to take some selfies and to post some cool content on their social media platforms. It's for conducting research, knowing about something, to discover something, to conduct some research which we don't know, and we wanted to know about how things will happen in microgravity environment. So that is why astronauts go to space and do different kinds of research in microgravity environments.
Yeah, if I'm not wrong, we can't hear any sounds in space.
Sound travels with waves.
Air.
In waves.
Okay, in waves.
Yeah, to be it flows with that, but in more scientific way, it travels through sound.
Okay, but can we hear sound in space?
Okay, it depends.
Because
if
it's
it can
vacuum,
propagate,
right?
If it can propagate in space, in space we can't hear. So that is why we use whatever the spacesuits that we are wearing on, like it will have different communication systems. Like as you asked me the question earlier, like what are the domains that are what kind of job, like what kind of domain or what kind of study that you want to choose if you want to be a space scientist, if you want to work in space industry, like even whatever the space suit you wear, okay, it is not made by one specific person. It has to go different things. Like for example, if you are traveling in space, if you're going to space, okay, you will wear a different kind of space suit. Okay, so when we are seeing some video of astronauts launching to space, okay, when they say some hi, they will be wearing a different kind of space suit. Okay. So when they are going to space, the gravity will be different. Okay, so and when they are coming from space, the gravity will be different. Okay, they will experience 5G gravity, the gravity 5 times more than what we have on Earth or something like that. So and the pressure will also be different while they are launching to space. They use different kind of space suits. And when they are doing some spacewalks outside the International Space Station or the space station, okay, the temperatures will be very extreme. The radiation or whatever you name it, there won't be oxygen. They can't breathe in space, right? So they have to wear a different kind of spacesuits. And the temperature will also be very different in space, right? So it requires different. Is it
like too cool in space? Like most of the part is cool, right?
It's too cool and it's too hot.
Okay, it's extreme.
Yeah, it's extreme. Like it can go above the 100 degrees Celsius and it can come down 100 degrees Celsius minus. Okay, so it depends.
And the thing with solar flares or something, it's
sometimes like it's not that dramatic as we see in scientific fiction movies, right? But yeah, it's also a
thing that we should look into.
Yeah,
if you go into space.
Solar flares, these are something we should be worried of. Okay, it depends. Not all the solar flares. Okay, so it depends. Okay, so some scientists are saying that maybe in 2025 or something like that, there is an like there will be some solar flare or some solar storm. Okay, so which can affect Earth environment. Okay, so
in 2025.
Yes, people are saying something like that.
Okay, now you're getting me scared.
No, like we used to hear that, right? Like in 2012, everything was going to end. Everyone was prepared to die. Okay, so that was just an imagination. Like it was just missed. People says that, some scientists and some people says that we missed that solar flare just 15 days. Okay, so based on that, like we were just 15 days, near.
How likely are we to die because of an asteroid crashing into Earth?
It depends on the asteroid size, okay, and it also depends on at what speed it is traveling.
Okay, imagine if the asteroid is in the, is in the size of New York City.
Let us imagine. Okay, so let us imagine.
It also depends on the speed that it's coming, right?
So let us imagine, like we generally listen that dinosaurs were died. Okay, everything was, like vanished because of the asteroid. Okay, so it was a size of 20 miles. Okay,
just 20 miles.
20 miles asteroid. Okay.
In radius.
Yeah. Okay. So it just,
it did the whole thing.
Yeah, it was a kind of extension level of phenomena happen.
Yeah.
Right. So it's just 20 miles. Even we were taking an example of tissue. Okay. So that tissue, if it is traveling at near the speed of light, it can also create that kind of impact. Must be more than that. Of course, it will create more impact than that. Okay. You don't have to throw that complete tissue if it is traveling nearly the speed of light. Okay, so for example, if you if you turn into the pieces, like if you make it 4 pieces, okay, 1/4 of the tissue can also create a lot of damage. Maybe we all died. Maybe in big city will be vanished. A city like Mumbai can also vanish if it is if it is traveling at the nearly speed of light.
A small piece of tissue can do that.
Yeah, can do that if it is traveling near the speed of light.
Okay, yeah. So it all depends on the mass of the thing and also the speed.
Yeah, like mass depends on speed.
Okay, yeah, good one. So light doesn't do any damage because it doesn't have any mass, because it's photon.
Yeah,
it's made of photons. Okay.
Kind of.
Okay, but lasers can do damage, right?
Yeah. That's why I said kind of.
Why is it? Okay.
Like,
they're all concentrated into some one
like
particular point.
Yeah, when you talk about waves or something like that, okay, waves or rays, something like that, it's a kind of spectrum. Okay.
Yeah.
It's a kind of spectrum. When you go to a hospital or some like what diagnostic center, when you go for an X-ray, okay, so there will be say that this is a radiation area. Pregnant women are not allowed in this.
Yeah.
Okay. So why they say that, all the rays, like there are different kind of rays based on the spectrum. What's the like, it depends on what kind of, how concentrated it is or how is that X-rays or gamma rays,
Different
UV
radiations
rays,
for
like
different
some rays of
spectrums.
some kind of rays that we are not, it is not friendly for us, right? So all waves are not friends to us.
Okay.
Right. It based on what we are talking and what situation that we are talking into, what kind of waves. Like we are talking about physics, right? Like when we are talking about physics, we need to be very, very precise. Everything needs to be proved. Like if I say some statement, like you ask me a question, right? Is there extraterrestrial life exist? If I say yes, I should have a proper statement. I should have a proper evidence for
Proof,
that, proper information for that, right? If I say not, it doesn't exist, even I should have a proper information. Okay, so even we don't know how big the universe is, right? It is too big.
Yeah.
We don't know how big it is too. Okay, we just know it's just big.
And it's expanding.
And it's expanding. If you don't have to talk, it is expanding. Okay, even it is not expanding, we don't know how big the universe is. Right?
Yeah.
So like I'm sitting here, okay, I can see like this, okay. I don't know what's behind me. Okay, so if I'm not able to sure whether something is behind me or something is not behind me. All I can see is this.
That's the observable universe.
That is observable universe.
Okay.
Okay, so that depends. So we don't know how big the universe is.
So the universe is expanding because of the Big Bang?
Okay, so from Big Bang, it is expanding.
What's there
After-
before Big Bang? What's there?
Yeah, that's the most interesting question.
Nobody knows answer.
Nobody knows answer. Hopefully, we know the answer. Let's talk about how Big Bang happened, how it happened. Okay, if we want to talk about Big Bang, okay, like scientists say that, okay, it started in very smaller space. Okay, all the billions of stars, everything started from a small space. Okay, it was very denser, trillions of degrees temperature. It was very small in the emptiness of space. Okay, so a lot of people says that universe was created by God. Okay, it is not created by some of these particles, something like that. Okay, so few people ask, okay, if you are saying that in this empty space, okay, particle can't be created itself, okay, who created this? God. Okay, God created this universe, let us imagine in that way. Who created God? There should be some person.
Yeah.
Okay, so if we say that God was created itself, there is a possibility even we talking really, through religions or some myths or something like that. Okay, if we are talking like that, even also we should believe that, like if God can create, God can be born itself. Okay, so these particles, everything can be created by itself, right? There is a possibility if we are talking in that. So it created itself. It was very denser. Like it was a kind of explosion, but not an explosion.
Okay. So I guess this is why most of the people I don't know if you believe in God or not, but who are into space exploration, like most of us, like we don't kind of believe that a person created all this.
Okay.
Like, there is this thing, like if something is created, there must be a creator.
Yeah.
And if there is a creator, who created the creator?
Yeah.
Right.
Yeah.
So this explains the whole thing again and again. Like this been the argument for like so many days.
Yeah. It's like a paradox. Okay.
Yeah. We can talk about paradoxes also.
Yeah. Like who created this? What created this?
You know that grandfather paradox?
Yeah. It's an interesting paradox. Okay. That explains when, we have to talk about it when we're talking about time travel.
But the thing is, scientifically, I don't know. Maybe according to physics, there is no way for us to travel back in time, right? Or is there a way? So far,
but some of the equations explains there is a possibility.
But we can only observe the past, but we can't go there, right?
Okay. So some equation says that, okay, you can go to past. Okay?
Okay. Theoretically.
Going to past means that it is not like you wearing some kind of helmet on, you sitting in a different chair. Okay, so you choose in which.
Yeah, bro, I have this doubt.
Yeah, in which like you want to go to 2000, 19 or 1800s. You want to see Jesus or you want to see God.
No, see, if I'm time traveling,
okay.
I'm sitting in this place, right?
Okay.
I have a time machine right now with me.
Okay.
If I set the time to like let's say just 1 month ago. This is February, right? I want to travel back to Jan. Where would I be if I would be into the same position of where I'm sitting right now? The Earth is traveling at a speed of whatever the speed it's going at. Okay, so if I just be at the same spot, if I time travel, okay, not on Earth but in space,
okay,
I'll just be left alone in the space floating.
If I have to tell you a proper answer for that,
you have to be in a time machine.
Yeah, I should have some experience going to past.
I mean, we have to take things into perspective from a bigger point of view, like on a massive scale.
Yeah, as we talked earlier, okay, time travel is possible. Okay, if you go in nearly speed of light, if you travel in space with higher velocities, okay, if you go a trip for 1 year or 2 year, 3 year or 4 year in space, okay, if you come back to Earth, okay, it will be 100 years after that. Okay, for example, if you travel to space, if you're going to space, okay, with some higher velocity near to speed of light or something like that, okay, so if you travel in space for 4 years with nearly the speed of light and you come back to Earth, okay, in just 4 years, it will be 4 years for you. Okay, so but when you come back to Earth, it will be futuristic. You don't know even Earth exists or doesn't exist, in what condition you will see the Earth. Okay, so you are going 4 years and you are coming after hundreds of years. Okay.
On Earth, it will just 4 years.
Yeah, but I'm people on Earth, it will be like hundreds of years. Okay, so when you come back, okay, you just spent 4 years in that spacecraft, maybe watching all the series on Netflix. Okay, and you came back, it's just 4 years, right? You will feel like you haven't completed all the series which are on Netflix. But on Earth, it is 100 years from where you have, from the year that you started. Okay, you can say it's a kind of time travel, right? You are into future. Like you can't
but
see,
that's what I'm saying.
Yeah, you can't see 400 years what will be like after 400 years if you're on Earth. Like definitely we will die, right? If you go to space, yeah, you can. That's a kind of.
I mean, it's relative.
Yeah, that's what Einstein said. Everything is relative.
Yeah.
That's what.
Yeah, so this is the same thing that I'm asking. It is possible for us to see the future if we travel at the speed of light or something, but we can't go back in time.
Hopefully, we will not go to back. I mean, we won't go back. There is no possibility. Like once Stephen Hawking said, okay, so there are some laws, or there are some theories. Okay, there are something we need to understand yet to explain this. Okay, how we can go to past, or why we are not able to go back to the past.
Yeah,
grandfather paradox comes into, like as you mentioned, that grandfather paradox comes to that. Okay, let us imagine I go back to time. I mean, I go back in time. Okay, I go back to time and like I killed my grandfather. Okay, let us imagine. Let's not talk about each and everything in the grandfather paradox. Let's talk about few points. If I go back to time when my grandfather is there. Okay, I killed my grandfather before he gets married. My father won't be there.
Yeah.
When my father is not there, definitely I'll not be there. If I'm not here, I'll not go back to the space. Who kills grandfather? This is about grandfather paradox. Like it's a kind of cycle that you can't give an answer for that. So time travel is something like that. It depends on what perspective that you are into, what kind of.
And also I think we can't say that we can't go back in time.
Yeah.
When there is no proof for us to not, to prove that it's not possible.
Yeah, few people says that, you are a cosmologist, you are a theoretical physicist, or you are something physicist. Okay, whatever you say, we can't prove it. If I say something, okay, so if I say something, it happens or not, it exists or not, we can't say that simply. Okay,
yeah.
So if I say it exists, I need to show some proper evidence for that. Okay, and if I say that it is not exist, I should show some proper evidence, some information to that, right? I can't simply say that this happens, that happens.
Yeah.
But few people thinks that we can just say that. Okay, if you have to prove something, if you're saying some statement, okay, in physics or in cosmology, in theoretical physics, if we say something, there are two ways we can prove it. Okay, so the first thing is that mathematical equations.
Yeah.
And the second thing is that you can prove that by seeing that thing happen. Okay.
Yeah, by observing.
By observing it. Okay. So even Einstein proposed this theory, right? Theory of relativity. The light.
And when it comes to proving things by observing, then there is other thing called Schrodinger's cat.
Yeah.
And that's confusing as well.
Yeah, it was made to confuse people.
Yeah, in a way.
Yeah.
So even that contradicts to a lot of theoretical physics, like whatever that we prove till now, like it doesn't matter to that particular theory.
Yeah.
Like, it only happens because you're observing it.
Yeah. Yeah, like
that blows my mind every time I read something like that.
Yeah, if it doesn't blows your mind, believe me, it is not physics, it is not science.
Yeah.
It's not that. It needs to blow your mind, right? If something is there which blows your mind, then you look at that. Okay, you conduct research, you do experiments, you fail, you learn, you come up with some improvements, right?
Yeah.
It takes a lot of time to prove something, right? And so Einstein proposed a lot of things, right? It took a lot of years. It took decades to prove. For example,
yeah, even after Einstein died for so long, now, I mean, recently we found out about gravitational waves.
Yeah, gravitational waves. Like now we are able to detect these gravitational waves very simply, all thanks to the equipment, all thanks to the technology. But Einstein, some information was given. He proposed a lot of ideas, right? Like black holes. We were able to see these black holes like 2 years, 3 years back, right? The first image of black hole was there.
Yeah, the thing is like how intelligent you have to be in order to just assume things that they are there, and then with technology, thanks to technology, that people are finding it.
Yeah.
Like whatever you said, where you don't even have proper equipment to see the moon.
Yeah. Yeah, that's what, like if you talk about this, taking the picture of black hole, we say that very proudly that it's an achievement in the astronomy or in the space sciences. I can tell you that it's a big achievement for computer science engineers.
Mm-hmm.
Okay, lots of data they need to look into.
Yeah,
okay?
And they need to process.
Right? So it's a kind of achievement for them too. It's for engineers, not just for who are into space sciences. It's an achievement that needs to be celebrated by other communities too. It was the greatest achievement that we have.
And mathematicians too.
Of course, they are everywhere.
Yeah. So you heard about the story about Srinivasan Ramanujan, right?
Okay.
His story completely blows my mind. Like he learned math on his own and did everything, and he made up his own theories as well, which we are using for a lot of things. In my personal opinion, I think that Srinivasan Ramanujan is the greatest ever human being that ever lived. I mean, when it comes to mathematics and theories that he came up with.
Maybe I'll not be able to comment anything on that.
Okay.
Yeah, like
I mean, this guy self-taught everything, and then he went to these universities, and then
maybe I can tell you that he is a genius comparatively.
I mean, of course, there would be some something that he might did wrong because of not proper guidance.
Yeah.
But in order for him to find things on his own, like which took a lot of people years to find, but this guy did all these things alone in his room or something, which just blows my mind.
Yeah, few people says that like these things comes to Ramanujan, like it comes to Ramanujan. He didn't explore, maybe like they came to him. Like a lot of equations, lot of things that he did. Now we are able to understand them, what he said long ago.
I mean, he kind of invented his own thing. Like people can't decode what he was writing because he didn't know like proper derivatives or whatever we call it nowadays. But he did all these things on his own.
Yeah.
And we could even find more in his notes or something if we keep on decrypting what he was trying to say.
Yeah.
right?
We don't know how many Ramanujans there on Earth. How many Ramanujans
Yes.
on Earth, like in India also. Even
Yes.
now, maybe back in times. Okay, so he got a chance. Like we say that Ramanujan didn't have proper education or something, but he got a proper platform. That is why we know him. Okay,
Yeah.
so he wrote some papers, some letters to the professors. Okay, so that is why he was called to there and he was able to do some work and it was published. Right? If he didn't get that platform, we never know who is Ramanujan. There could be people who are more genius than Ramanujan, but we have never seen him.
But we have never seen, yeah.
Because he didn't get proper platform or something like that. Okay, maybe there are no people like Ramanujan. We can't simply comment on that.
I mean, yeah, that's just a personal opinion
Yeah.
of mine.
Yeah.
Because it is fascinating to see someone with
Yeah, it
no
always
formal
fascinating.
education.
Yeah.
He did all these things like that we use till now. He found out so many things.
Yeah. I hope one of the equation that comes to mind, I'll be also. I can call myself some mathematician or some scientist or something like that.
You're into math as well?
I'm not into math, but wherever I go,
Math follows you.
yeah,
Yeah,
we can't leave math anywhere.
Yeah, we can't leave math anywhere. If we leave math, we're gonna. I think if we don't calculate, everything is related to math, in my opinion. Like even if we're seeing, like our vision is somewhat related to math. If we can put everything down on paper.
Yeah, of
with
course.
math.
Like we know, like we doesn't know that we are doing math, but
Yes,
we are
exactly.
actually doing the math.
Everything
Yeah,
relates
like
to geometry.
you just set up this mic, right? Just few minutes back. You just know how, like, what's the volume that I speak, like how loud I speak. Okay, and you know the capacity of this mic, right? Based on that, you have calculated this much space is enough from the mic and my mouth. That will be good in this podcast, right?
Yeah.
Based on that, like you calculate everything. We calculate everything, like for the while you are taking, while you are shooting on that camera, like you do thing, right? If you want to cover that to till that space, this space, like you need to be in this distance or you need to be this close. That's what math.
Everything
Yeah.
revolves
Yeah.
around math, even if you like it or not.
Yeah, people says that I hate math, but they do math.
Yeah, they do math.
They have to do math.
Yeah, even if it doesn't revolve around numbers.
Yeah, it's just some kind of calculations that we do.
Yeah, everything revolves around calculations, and everyone's a mathematician.
Yeah.
At heart.
Yeah, like that's what, right? Maybe you are coming to this location, maybe you are somewhere, like you see in Google Maps, right? It will take 40 minutes or 50 minutes to come here. Like it completely math. Even you say that you don't have to see Google Maps. You can, if you're the person who is traveling in this area, okay, you know the traffic, you know at what speed you can go and what's the kilometer, so that you can tell I'll be there in 10
Yeah, in some
minutes.
cities we calculate kilometers, in some cities we calculate time.
Yeah, right. Like if you're going on some more, like, if you're in Bangalore, like you have to travel 2 kilometers. Okay.
We calculate
We
time.
calculate how much time it takes. Like it may take 30 minutes, 20 minutes, 40 minutes, and what time that you are in.
And if you're traveling in Mumbai, you calculate how many days it's going to take
Yeah,
you to
maybe.
travel 2 kilometers.
Yeah, that's what. Every time we do math, right? Every time we do math, even we like it, we don't like it.
How long is it going to take for us to reach Mars, for example?
It depends on at what time we are launching it.
Again, and the speed.
Yeah, again, and the speed, and when we are launching some satellite or some rocket to Mars, okay, so it depends, okay, where is the Mars and where we are, like what's the distance between the Mars and, like, for example, how it actually calculates is that, okay, how do we calculate it? For example, Mars is somewhere and we are somewhere, okay, so we will see at what point, at what time Mars will come closer to us. Okay, so if it comes closer in the month of June, let us imagine as an example, okay, if it comes in the month of June, okay, so we make sure that, okay, it's the nearest point for us, right? We make sure that this satellite reaches that point at that specific point of time, right? It depends on all calculations. We call it as orbital dynamics or astrodynamics. Okay, so we do calculation in that
on
domain.
average,
It takes like 6 months to 9 months.
6 months to 9 months. Okay, that's a lot of time.
Yeah.
And how do these astronauts like survive? Like how do they eat? What kind of food they eat? Do they get to choose their own food?
Yeah, like when we are talking about what kind of foods that astronauts eat, they are similar kind of foods. Okay, not same. They can eat similar kinds of food. As we can say.
Do they get to choose what they want to eat?
Yeah, maybe. Yeah, maybe you are allergic to something. Okay, I'll tell you, this is my food menu. You have to eat this in the next 6 months. You are allergic to some food. Okay, definitely you will not be interested to eat it.
Yeah.
And it's like there are hundreds of foods, okay, where you can eat in space. Hundreds. Okay, the count is going up, going more and more and more. Okay.
I could eat pizza?
Yeah, you can eat pizza. Like it's been from very long. Pizza Hut was the first restaurant, okay, to deliver food into space. It doesn't mean that delivery boy from Pizza Hut doesn't deliver the food to space, but
okay.
they have done little, processing. Because it needs to be good in space, right? You can't simply cook in space. You will not have like whatever the...
So everything in space is just processed before?
Most of them. You can do little cooking there, but we can't call it cooking, right? So when we go to kitchen, like we have certain things when we are talking about cooking, right? But in space it won't be like that. They are rehydrated foods, okay? So it will be like no hydration will be there, no fluid will be there in the food, okay? It will be dried or something like that, okay? All you have to do is that you fill that with some fluid or some water, okay? You heat it up, it will boil by its own, like in oven, okay? So in oven...
If I want to drink coffee in space, how would I consume it?
It will be in pouches.
Okay.
Like
I just have to...
Like you will not have that kind of cups there.
Okay.
Okay, it will all with pouches.
Okay. Just like how we take sips from that fruity or something.
Yeah, exactly. Okay. We have Tetra Packs, right? We put some straw in it and we eat. And if we take the same straw and the same design of the Tetra Pak, it won't work there. Okay, because of the microgravity within the straw, the fluid will come out, right? Even it is very small space, but it will not go that forcefully, but it will come by droplet to droplet. It is not also recommended. So the design of the straw is very different in space, right? You will have a clamp to that, you can just close it, okay? When you, giving an example, when you are ill, okay, you go to some hospital, you will get some saline, right? Some bottle. Like when you have that, you can control at what speed it goes, it flows, right? Like that you can just, there will be a clamp, you can close it, so nothing will come out. You open it to zip it. So nice. Everything for space needs to be customized, okay? Like it needs to be designed in a very different way.
Nice. So there is someone out there designing straws for space travel.
Yeah, of course. Like it's a whole big domain. Like, what we see there are like, for this podcast, you and me are talking, okay? If you see, we are the only two people here, but you have a crew to to design it, to edit it, and to record it, right?
Yeah.
There are like that in space also. Like every domain is there, but it's just that we see astronaut and we see astronauts are eating food, but there are a lot of
I
people.
think computer science guys have been like they're playing a big role in like how we grow so exponentially in the space travel and things like that.
I'll tell you that there is no big domain in space. Okay, so if the communication engineer are giving you super, like, okay, it is going very nice, okay, but something went wrong, okay, that your mathematician gave you a wrong calculation, okay, by the time you reach that point, Mars should be there. If you can't see Mars because of the calculation, then astrodynamics is a big part, okay, and you go there, Mars, okay, you need to communicate with Earth, okay, if something went wrong, okay.
The communication. People thinks
that you are died, like the movie, like there is the Martian movie. So the people thinks that they died. Okay, communication is also very important. It also plays a very important task. And like the same, like you have an oxygen. Okay, that person who calculate this much oxygen is required when you're going this much gravity. You're going like this. If he calculates something, you will be run out of oxygen. You will die.
Yeah.
Even that person is also plays a very big part in that. Even coming into the food, okay, if the nutritionist, okay, it doesn't calculate how many nutrients are required for you, okay, if they do calculate.
Okay, so I've heard that you need to have like 10 milligrams of iron consumption if you're in space.
So when you are in space, the red blood cells will be lesser. Okay, it will be very lesser compared to on Earth. Okay, so most of the iron will be consumed by RBC. Okay, so when you consume more than 10 milligrams per day, okay, in your food, what you consume, the astronauts, when you are an astronaut, okay, when you're in space, like if you consume more than 10 milligrams of food, iron, so it will be like
there is a possibility
that you'll get cardiac arrest. Okay, so the people who are developing the food scientists, okay, especially the space food scientists, okay, thinks about it, talks about it like that. So they make sure that the iron in the food that you consume is less than 10 milligrams. Okay, so that is the possibility. So for that.
And how about how do they get vitamin D? Do they get supplements for that?
Yeah, like you and me, we are on Earth. Right?
Yeah, we get sun.
We get sun for free of cost.
Yeah.
We get vitamin D. Right. Still there are people like vitamin D deficiency, even they are on Earth. Right. There are people on Earth. There are people on space. They're in spacecraft because we have certain things in Earth environment. Okay. So whatever that is that we are coming to us are safe. But when you are in space, you will not have that kind of layers and atmosphere, right? Yeah. You will get radiation directly from the sun. It is not really recommended for you, right? Yeah. So we have certain things which will be, which will give you support, which will keep you safe in the spacecraft, the systems of the spacecraft, thermal technology, different technologies that keeps you safe. But for that purpose, you will not get sunlight, right? You require vitamin D. So they take vitamin D supplements through different foods. So that is and how sodium, they get vitamin D.
Same thing goes with sodium?
Yeah, they need to take little less because of the bones and these things, right? So they have to take very limited things.
Yeah. So talking about different domains in space, chemistry also comes into play when it comes to the food consumption and all that.
Of course, like you are eating some kind of food, okay? You want some food. If you are an astronaut, okay? You're telling me that I am the food scientist for you. Let us imagine I am not a food scientist and you're not an astronaut. Let us imagine you are going to space. You come to me and say that these are the foods that I am interested to eat in space. Okay, so I'll come up with a menu plan for you. Okay, I have my own nutritionist. Okay, dietitian for me. Okay, so these are the nutrients required for me when you are in space, when I am in space, or when you are in space. Okay, I'll tell you these are the things that are required. Okay, I do plan your meal plan. These are the foods that I wanted to do. Okay, these are the foods that I wanted to give you. These are the nutrients required. So this will be the pouch that you need to take. Okay, so like that, I'll give you this kind of proper menu for you based on what you are interested in. If you ask me, bro, I wanted to have some vodka in space, like we need to think about it.
Okay.
But you can choose what kind of foods that you want to eat, but whatever you want to eat, everything that can be done for now.
Yeah. So it is completely fictional when it comes to space and people just taking pills.
Maybe you can take pills, like what people thinks is happening, that's the fiction. Okay, people from nutraceutical background, few people from this, we do a lot of research, like from organization like us. Okay, so we are one of the people who's aiming to create space food for astronauts. Okay, so our major domain is into space food. Like now we are still figuring out how we can make this happen. Okay, a food meal in just a pill. Okay, like we call it meal in pill. Okay, you just take a pill, you'll getting all the nutrient supplements, whatever it is required for you.
But
it is just kind of fiction.
Yeah, okay.
We are working on that. It is not reality. It's the fiction. Okay, what people thinks that maybe astronauts can eat whatever the foods that we eat. They think that it's like fiction. It is not happening. They take pill, but the reality is that the pill is the fiction, and what we eat in space is the reality.
Okay, we can eat everything that we can eat here, but with some science to it, like with some chemistry and all that. Nice. So yeah, talking about Mars.
Okay.
Is it too hot for us to be there?
It's too cool. It is farther than us, right?
Okay.
We are here. We are the planet. Okay. It is 50 million miles away from us. 50 million miles away from us. Okay. Whatever the sunlight that we get, it will get little less. right? We are in a habitable zone, right? Because we are in the right position, which can make us habitable, which can make the planet habitable. If we are little closer to Earth, we will get too much temperature, right? If we are if we are little farther, it will also be not convenient for us, right? It depends. Okay, so Mars is 50 million miles away from us. Okay, it gets little less temperature than us, right?
Okay.
It is a little cold than us, and the Earth's atmosphere. Okay, whatever the Earth's whatever the sunlight or whatever the temperature that we are getting on Earth. Okay, it will not go out that much. Okay, it reflects, right? Everything reflects. When it is going reflection, okay, the Earth's atmosphere keeps it warm. Okay, it keeps us warm. The temperature which we get to Earth, it will not go out. But as you compare it to on Mars, the atmosphere is 100 times thinner.
Okay.
On Mars, okay, compared to Earth. So the sunlight, the temperature, even whatever the less amount it is coming, it will go away. Okay, the temperature on Mars is cool. If it is in winter, there is possibility that you will be like you see some cartoon. Like you keep it in some refrigerator, you will be turned into pieces, right?
Oh, okay.
Like you can be like that. Okay, so you will be freezed to death.
Okay. Do you think it's possible for us to, like whatever Elon Musk is doing, do you think it's possible for us to do in like maybe next 50 years or something? Do you think we can colonize Mars?
Of course, maybe with some. It depends on what kind of technology that we are using and what are the situations like. Science and technology is all about making things happen which are impossible. Okay, so if everybody can, if everything is possible, okay, or if everything is easy, like what's the speciality of being a scientist? What's the speciality of being an engineer? Your task is to make impossible to possible. That's what.
Yeah. Okay, so we can colonize Mars in the future.
Yeah, in future if we go in a proper way.
Let's talk about parallel universe. Let's just imagine in a parallel universe, is there a person like you and me? Maybe we'll be sitting in the opposite direction. You'll be the host and I'll be the guest. How would it work? I mean, the multiverse theory.
Yeah, the multiverse is like, as we talk about, again it comes to expansion of universe. Okay, we talked about universe is expanding. Like this parallel universe says that it's a bubble. Okay, it's a bubble. The bubble is expanding itself. The bubble is expanding itself. There could be other bubbles. This is our universe and our universe is expanding. This is our bubble. One universe is a bubble. There can be 100 bubbles outside. There can be 1,000 bubbles outside. Every bubble is a universe. There is a possibility that people like you and me sitting and talking in the same podcast in another universe. It is possible. It is not possible. Right? Unless we have some proper scientific evidence, scientific information to say that, we will not be able to say anything in a proper way. Like we can't
guarantee it.
Everything is a paradox. Everything is hypothetical until we get some scientific evidence to that.
So expansion of universe, we've been talking about it for so long, right? How is the universe expanding? Like,
okay, so after Big Bang. Okay, so as I told you, Big Bang was started from very small space. Okay, all the universe, like all the galaxies are started from there. Okay, it starts to expand. People say that it's a kind of explosion, but it's not an explosion. It's an expansion. Okay, it just expands into what? Into itself. Okay, it doesn't expand into something. It expands into itself. Okay, so it will be like, for example, if you're baking some cake. Okay, if you keep some raisins or if you keep some objects on it, okay, so when you're baking the cake, it will be like near, right? If you keep it 1 centimeter, 1 centimeter, 1 centimeter, if you keep 10 things there on the cake, okay, or maybe on the bread you bake, okay, when you're baking it, it will expand. It will expand into it, like, right?
And the distance between those particles?
Between the particles will also go further. It happens with the space. Okay, so this whole concept came from the Einstein's theory of relativity. Again,
we all come back
the
to
modern
this.
physics, that what we are talking, what we are doing, everything is related to Einstein theory of relativity. That's why we call are you an Einstein? Okay,
yeah.
That is why everything is related to this theory of relativity and Einstein's things. Okay, so again, that Okay, so it expands into that. Okay, when it is expanding, the distance between every object, every galaxy changes. Okay, so this concept was came by Friedman. Okay, or Friedman, whatever you call it. He's a Russian physicist. Okay, there are in theory of relativity, there are Einstein field equations, if you talk about scientifically. Based on that, he came up with an idea. Okay, universe either expand or either it can, like shrink. It is not just as it is. It is just shrinking, or it is going like that. It was the thought of that scientist or the physicist that came upon. Later, Einstein also worked on it. Okay, everybody is saying that, most of the scientists are believing that this universe is expanding. Okay, so like that, when we talk about Big Bang, okay, so we were talking the gravity is too high, right? When it is, when it is going, when it is expanding, the gravity should be pulling, like the gravity should be attracting it. Okay, so when in the starting of Big Bang, if it starts to expand, it is supposed to, the acceleration of expansion should come down, right? Right, because gravity is stopping it.
Yes.
But instead, what we found is that it's quite interesting. It is accelerating. It is supposed to come down as it is going in time, but it is actually accelerating nearly the speed of light. Okay, as it is expanding that much. Okay.
Why is it happening?
This is what scientists are working. It's a kind of repulsive gravitational force. Okay. It is not going against. Okay, so gravitation should be holding these things up. It should be. It shouldn't be accelerating. It should come down the speed.
Yeah, at some point of time, I think the energy should come down. The energy should die down, and things should slow down.
Slow down, but it is expanding. That doesn't mean that some energy is not going against gravity. It's just repulsive of gravity. Okay, nothing going against gravity, but it's repulsive gravitational. We call it. Okay, it's not against gravity, whatever we call it. Okay, so it expands like that. Okay, it expands into itself.
I mean,
the space is going bigger. And the distance between planets, the distance between stars,
galaxies, stars.
If it is going in this way, okay, in the same acceleration, okay, if it going in the same way, if in the same speed, maybe after 1 billion year or 1 billion years away from now, okay, after 1 billion years, maybe we'll not be able to see these many stars as we see now, because the distance between the stars and going farther away.
But is this where the dark matter comes into play?
Recently, there are some scientific people are saying that because of dark energy or dark matter, this is happening. So it's still like we are advanced, but we are not that advanced in terms of astronomically. Okay, so 1,000 kilometers is a distance.
I mean, we can't observe something that we can't see. Sorry? In a way, like the dark matter that we're talking about, right?
Okay. Yeah, the universe consists of...
It's all theory. We can say a lot of things in math.
In space, like whatever we see, whatever we don't see, even we call it vacuum, but it is not completely empty, right? Whatever we see, this is matter, you are matter, and I am matter, right? We are only less than 5% in the whole universe, which we can see. There is dark energy, there is dark matter, which is something, okay. So the whole, if you see the composition of universe, okay, our matter, what we can see, the matter is just less than 5%. Okay, dark matter is around, it counts for somewhere around more than, the rest of the time, dark energy and dark matter. We are less than 5%.
The matter.
Wow. These experiments are happening. Okay, so the existence of dark matter was, came in, I mean, it was, we can say it was a turning point for that. There was a scientist called Paul Dirac. Okay, he come up with an equation that existence of antimatter. Okay, if there is matter, there is antimatter, something like that. Then there are, I mean, these kind of people, I'm not sure what exactly is that. He's that scientist, I'm not sure quite though. But he was one person, like, I don't know whether he's antimatter or dark matter. It is quite different. If there is matter, there should be antimatter, right? So, like that.
So that's how it happened.
Maybe it is the possibility for that, maybe it is not. Okay, it's just the possibility, like we are advanced, but we are not that advanced to give a statement on those kind of things. We are yet to discover them. We are yet to learn a lot about it. We are thinking that we know 5%, we are not supposed to know 95%, but we are not sure whether we know 5%, 1%, or 100%.
Yeah. We can't scale it.
Yeah.
So in dark matter, like we see some things, right? Like you talked about black holes.
Yeah.
And we got a picture of a black hole. But people say that even light can't escape a black hole. And if we have to take a picture, we need to have some light.
Yeah.
In order for the sensor to recognize it.
Yeah.
And how did we take a picture of a black hole?
Okay, so this is an interesting question. Okay. Okay,
Yeah.
so see, what black hole is, why we call it black hole? Okay, so because not even light can emit from it. Okay,
Yeah.
so light travels at very speed, right? It's about 3 lakh kilometers per second. It travels with that speed. Okay, the gravitational pull of the black hole is that high. Even a thing which travels at 3 lakh kilometers, nearly 3 lakh kilometers per hour, cannot escape from it. It is that the gravitational pull of that black hole is that high, that extensive, right? So it cannot come, but it emits radiation. That's what we call it, Hawking radiation. Okay, so how they capture the picture? It's not like that. They go nearly to the black hole and we captured it. Okay, so there is Event Horizon Telescope. It's not one telescope. Okay, there are different telescopes which are linked as one single telescope. Okay, to frame it. Okay, there are a lot of processings happened. The radiation that comes from that, and the light passes through the event horizon. Okay, so even you see the black hole, the picture of the black hole wherever you see in a movie or wherever you see in the reality. Okay, the black hole will be black. Okay,
we're not seeing the black hole.
we are actually seeing the
event horizon.
Event horizon. Okay, the black hole will stay black.
Nobody would know what's beyond the event horizon.
Yeah, because even light cannot escape from the event beyond the event horizon. If you want to go take some pictures there, if you want to take selfie inside the black hole, you should exist that gravitational pull, right? You should be able to do that. The gravitational pull is very, very higher. When you go to some other planet, when you go into space, let us imagine my weight is 100 kgs. Okay, if I experience 10 G, my weight will be like 1000.
Yeah.
Can I bear my own weight? Okay, now we are talking the gravitational pull is so high. You will not know how the body will be like. You will be turned into pieces.
You will be spaghettified.
Yeah, you will be shrinking. Like, we actually don't know how the body actually reacts. We just know that even light cannot come out of that. Okay, what we are saying about is that even the thing which travels at 3 lakh kilometers per second cannot come out. We don't know even an object which goes with 5 lakh kilometers per second can come out or not. We just don't know. We just know the highest thing that can travel. The thing which goes.
I think even the imagination of you getting spaghettified if you go into a black hole is like they just calculated this in a slow-mo way, right?
Yeah, we have to talk about it in a different way. Why? Because we have already talked about the topic. Okay, the more speed, the more velocity that you travel in, like if you speed near to the light of speed, okay, your race will be less. The time will go slowly as you compare to the. In the same for the gravity also. If you watch the movie Interstellar, right? Some astronaut stays in some deck, okay, in some module, and some 2 astronauts or 3 astronauts will go to some another planet. They spend like 10 minutes or an hour or something like that. When they come back, it will be yes for him, right? Just because it is near to the black hole. Okay, so the gravitational, it is a very heavier body, right? The time will run slowly for them. Okay, when you are there, you spend a second there, it will age years on Earth, right? So it depends on. Like even we talk about science fiction, we'll not be sure what we are talking about. We are talking about speed, light of speed or something like that. The only thing that we know that can travel at 3 lakhs per second is light. So that's why we are telling even light can't come out. Okay, if you like from now, 1,000 years from now, okay, so a scientist like you maybe developed a spacecraft, okay, designed a spacecraft which can go at 5 lakh kilometers per second, nearly, okay, maybe more than that. We are not sure if you go to a black hole whether you can escape from that gravitational pull or not, because we really don't know what's the gravitational pull of that black hole. And from black hole to black hole it is different, okay, from black hole to black hole it is different. Like, it depends on what black hole that we are talking. Like, black holes can be different in size, right? Like the planets, okay, the size of other planet won't be similar to us, right? It can be bigger, it can be smaller, like the black holes also. It can be a massive black hole, it can be a supermassive black hole, it can be something.
Okay, so nobody knows what's beyond that event horizon of a black hole.
We actually based on some...
Do we have any theories like what's inside there?
Yeah,
is it a singularity or something?
It's a kind of wormhole, okay.
And people say like there is a singularity.
Yeah, what singularity is that? Okay, so this fabric, again, coming back to the general theory of relativity. Okay, you have to come back to that to explain everything. Yeah. Okay, so we talked about it. It acts like fabric of space.
Yeah.
Right. A small gravitational object will create a curvature in space, right? A band in space. So it will be attracted, right? It will orbit. It will attract things because of the gravitational pull, because of the curvature. Okay. The more the more the object is, the more the mass is. Okay. The more that is, how big it is, the curvature will be also like that. The gravitational pull is based on that. How mass, how weight. How big it is.
How big is that?
And how massive it is. Bigger is not, it can be a very big, it can't be that mass, right? It depends on the mass of that object. For example, how massive it is, based on that it creates a curvature. The black hole will be very massive, okay? If it is a normal massive black hole, it creates a curvature like that. Okay, it's the singularity. That's what we call it, singularity. Like we generally, when we surf on internet or maybe on Instagram, okay, we see memes that, right, black holes will have a curvature like this. Generally, if sun and planets creates a curvature like this on the fabric of space, but it is that massive. Okay, it creates like this. Okay,
I think if you want to travel faster than light. We talked about wormholes, right? You just said maybe it's a wormhole. A black hole
like people,
could be a wormhole.
There are some explanations, okay? There are some theories. I can't say theories, but some kind of paradox or some kind of explanation. People argue that this can happen. Okay, if you get into a black hole, there could be a way to another universe, or maybe somewhere to another planet, or somewhere on another galaxy, or maybe you get into a black hole, you can die, you may die, or maybe you can be alive. We don't know. You can be alive, like you go to some another universe, you can go to some another galaxy, you can travel somewhere very beyond our thinking. There are some kind of, lot of explanations are there based on that. Every single day, a new perspective.
Even when we come to talk about how the wormholes work, again, I think we have to come to the space fabric example.
Yeah, the same fabric example, but black holes, we have, we have mathematical understanding how black hole works. We used to see that in films, like how black holes actually work. Now we are able to detect where black holes exist. There are thousands of black holes, and every galaxy, in every galaxy we have a lot of black holes. Okay, even in our own galaxy, right? But the existence of wormholes, we haven't detected it yet. So it's still in the state of theory. Okay,
yeah.
We are expecting wormhole exist, but not yet. We haven't discovered it. So it's not that we don't know how it looks, we don't know how it actually works. It's just like that we haven't known. Somewhere maybe 100 light years away from it.
So can a black hole be a wormhole as well, if it gets proven?
Few people says that I'm not a scientist to say that, like
theoretically is it possible
to testimony whether it is right or wrong. There are some sayings that other side of the black hole is a wormhole.
Yeah.
Okay, so this is from this side you see it a black hole, and the other side is a wormhole. Okay, so there is a possibility, there is not possibility.
Yeah, this is like we can explain wormholes with a paper, right?
It's just a fabric of space. If you bend it, if you put a hole in it, like if this one end is a wormhole and another wormhole is a wormhole, if you have to travel through like this, it takes 100 years. If you go like this, it takes lesser time to reach it. Like it's just like if you are in a big apartment, okay, like to navigate an address, like if you, for example, if you are in cellar, if you have only this way, if you have to travel like this, you have to go to another street, you have to take another lane, right? You have to enter the same building. But if you can enter through that building, it will be very easy. Like you navigated me to this location, like I was on the other side of the building, the entrance of the building is on the other side. Like there are two ways, right? You either have to go back and go to the before lane. Okay, it takes a lot of time to come, like 10 minutes or 5 minutes based on how big the lane is, right? If I can enter some apartment and like this, it will be easier for me to, it's just a matter of 1 minute, right?
Yeah, but it's really hard for us to, I mean, I think there is no wormhole yet.
If there is an entrance, okay, it will be easier. If I have to dig it, it takes a lot of time.
Yeah.
Like it depends. Still, we need to do a lot of research.
I think we're gonna find out if someone goes into a black hole.
Definitely, if wormholes exist, we will travel near to the black hole. We do a lot of experiments on wormholes, but the point is that we will not be alive by that time because it takes 100 years, 1,000 years. We don't know. Maybe whether we can do that or not, because it is not that near to us. Okay, even we have a technology where we can get into black hole. Even you travel at light speed,
it may be like 3,000 light years from us.
If it takes 3,000 light years from us, if you travel nearly 3 lakhs kilometers per second, okay, 3 lakh kilometer per second, okay, in 1 year you will go one light year. Light year is nothing but
how much a light travels in a year.
In a year. Or in how much travels in a minute or something. It's just like that. Okay, so, if you have a planet where it is habitable, if it is like like we generally talk about in science fiction, Proxima Centauri, it is the nearest things we think that there could be possibility for human life, or it can be habitable. Okay, but it is like 4 light years away. Okay, so if with the technology it takes which is 50 million miles away from us, Mars, it takes 6 months, 9 months, right? 4 light years away. Even you travel at 3 lakh kilometers per second, it takes 4 years to reach. With the technology, it is impossible to reach.
Yeah, as of right now.
Unless we don't die for a lot of years.
Yeah, and for the people who are inside that particular thing which is going at a light speed, maybe even after they're reaching to that Proxima Centauri, they can't communicate back to Earth because maybe everyone died because of some asteroid crash or something on planet Earth.
So maybe if you have watched a movie, Passengers, okay, let me give you an example of movie because people are interested in science fictions. We all love that, right? So in that movie, that hero, that main character wakes up 90 years ago. Before reaching the destination, it takes 120 years. He'll be in the hibernation for 30 years. He wakes up at 90 years early. Okay, he wants to communicate with some person from Earth. Okay, it tells that it takes time to go reach the Earth and to get a response from that. It takes 55 years. Okay, even you have the technology to reach Mars or some another planet. Okay, even you're traveling at that speed. Okay, even you have a technology to go to some another planet which take 120 years. You have hibernation pods and lot of things. Okay, even it is taking 55 years. Okay, to reach that locations, it is very hard to communicate with people from people.
Yeah, so I think we got enough content for this.
Yeah, maybe.
Yeah, this has been a really interesting episode till
Hopefully.
now that we did it, because space is like the most interesting topic for me. Like I have so many questions and I have a lot of things I need to learn, and I learned a lot of things from you.
You are asking me a lot of questions about space. Even I have billion questions to ask.
Yeah, so hopefully we're going to do another episode as well. And I also want to know that you are promoting space science and all, which is really cool. Like people who everybody wants to learn about how things would work in space, like how I can become an astronaut even if I have something like medical background or something. And right now you guys are doing something similar to that, where you are just educating everyone regardless of their domains and teaching them it is possible for you to get a career in space, even if you're not an aeronautical engineer or you like something that's related to space, which is really cool. What's the name of it again? Is it SpaceSkool?
SpaceSkool. Yeah.
School with SKOOL.
SKOOL.
Yeah, that's really nice.
Yeah.
All right. So yeah, it's been a really nice episode. Thank you for coming.
Thanks for having me here.
And hopefully we're gonna do another episode, and where we could talk more about wormholes, teleportation, and black holes.